Hi everyone, welcome to the Ethical Hackers Workshop. Um, I'm Nick, I'm the President of the Society. I'm also here with my committee members, Mac, Chloe, Brooks, Soyeon and Nikki. I'll just say a little bit about the Society and then we'll get onto the workshop. So we started the Society with the aim to bring together people interested in cybersecurity and ethical hacking. We host sessions every Monday between 6 and 8 p.m. on Blackboard Collaborate, and you'll need a membership to be able to get into the sessions. Basically for semester one, we're aiming to do more beginner-friendly sessions. So if you haven't done anything to do with ethical hacking or cybersecurity beforehand, you should be fairly easy to come along to those. However, second semester we'll get into some slightly more advanced, interesting tools, techniques that you might want to use for both attacking and defending. You can view a lot more of our information and sessions that are going to come up at chefesh.com. So the skills taught in this workshop will allow you to strengthen your security in your hackathon and also hopefully future projects. Unfortunately, we can't show any actual hacking in this walkthrough because that would be against the MLH Code of Conduct. So if you want to view any sort of ethical hacking, you can obviously come along to our sessions on Mondays if you've bought a membership, and you can find the memberships on our website.
The first thing we're going to be talking about is using Git. Now we all know it, we all hate it, and sometimes we love it too. It's really useful, but how can it be made safer? So most of you will have used Git before, but if you haven't, it is an amazing tool to use if you know how to use it properly. A hackathon is the perfect place to start to use it if you haven't done before. As you can see in the picture, Git allows you to see who has made changes to your code and what changes have been made. As you get used to it, you will find loads of more useful features. In this section, we will show you some of the top security considerations when using Git. To start with, attackers can very easily steal sensitive metadata that can be found in the .git folder. Now this folder can store so much data about your project. It's basically how Git shows you all the changes you've made. One way to protect against this is to restrict read and write access for this folder and make sure you list any sensitive files in your .gitignore file. Once it's pushed to Git, it's there forever. And there are even bots that search repositories for passwords. If anyone and everyone can access and edit your project, you are likely to have people who will alter or even steal your code for malicious purposes. Make sure you know who is a contributor to your project and try to keep repositories private until deployment when possible. Finally, and most importantly, is using a secure connection to Git. Using an insecure connection allows attacks such as man-in-the-middle and any interceptions. If you take one thing away from this section, it should be to use an SSH connection with Git wherever possible. So, these instructions should all work with Mac, Windows and Linux when you use the terminal or Git bash if you are using Windows. So first of all, you have to generate an SSH key, and to do that you use the command in step 1. -T RSA will choose the RSA encryption method, -B specifies the key size, and -C can be used to label your key. So for instance, if you've got a lot of different keys, you might label it with, computer or laptop or something like that, just to make it easier. You should receive a message similar to that in step 2 that will tell you that it's been generated, and you have to save it to a file. When you are prompted for a passphrase like in step 3, please make sure you use one and make it a secure passphrase. This will mean when anyone tries to get into your key file that they won't be able to unless they've got the password. The generated files must have the permissions stated on the slide to ensure the security of your key pair. So again, making sure it's only accessible by certain groups and users of your computer. So now that you've set it up on your laptop, you need to add it to GitLab or GitHub. So first you need to read the contents of the public key file, which is step 1. And step 2, you need to copy this public key and navigate to the add and SSH key pages for either GitHub or GitLab. These are shown on the slide. Paste the copied public key into this page and fill in the other fields to complete the setup, and click Add Key. So this is what the GitHub page should look like. As you can see, there's a title and a key. And it's very, very similar for GitLab as well. So to test your connection, use the appropriate commands for your Git platform. You will be asked to authenticate the RSA fingerprint for your first connection. If you connect successfully, you will be shown a welcome message. And that's pretty straightforward. If you do have errors, it is a little bit complicated to fix, but the internet should help you out with any of your problems. To actually use the SSH connection, make sure you clone the repository using the SSH URL instead of the HTTPS URL. And an example of this can be shown on the slides.
Our next topic is database security. As you grow your application, you're quite likely to need to store more and more data, and as you do so, you're likely to end up using databases. But these databases aren't secure by default, and they require some effort from you, the programmer, to ensure that your data and the user's data is kept safe. So, why do we care about database security? Well, not only is it a place for all of your application data, but it's also a place for all of the data that your users store on your site or service. Now this is important because you need to think about their data privacy. Just because you're not a business doesn't mean you don't need to think about the GDPR and protecting your users. An exploitation of your database could not only link or leak information that's important to you or your application, but also that's really important to your individual users. It could contain payment information if you're saving that sort of thing, or just their email addresses, or even worse, passwords. So, how do you secure a database? Well, one of the easy ways to ensure that your data isn't stolen is to encrypt the data that goes into your database. This requires any attacker to have not only access to the database itself, but also to your secret encryption key that you've been using. So there are three common methodologies for doing this. The first thing you can do is what's called application level encryption. So this is the API method. Now, in this case, your data is encrypted within the application itself. Now, this can sometimes cause issues if you're encrypting large amounts of data, and it's certainly complex for you, the application designer, since you're the one who needs to worry about it. However, it's available for all types of databases and is quite flexible. You can encrypt just individual fields, or whatever bits that you find important. Now, there's another approach, which is this plugin method. So here, instead of relying on the programmer to write their application to handle all of the encryption, or relying entirely on the database, you can use a plugin for the database that kind of sits between your application and storage, and as you save data to the database, it encrypts it, and when you ask for it back, it'll unencrypt it for you. This is a nice middle ground, but it still requires some thought from you, the programmer. The last method, of course, is this method, which is the TDE method, which stands for Transparent Database Encryption. The reason this is transparent is because it's done entirely by the database on the back end, and you, as the application programmer, are unlikely to need to change anything in your application. It's very helpful or very easy for you for that reason, because you don't have to change much. But occasionally you miss out on some of the flexibility that you can get with the other methods. So now, an example, or here's rather just some pictures to show off how these different systems work. So here's, say, a web server. This is whatever application you're likely to write that's using a database. So this is your side of the code, and then this is the database program. So in the API method, or the application method, you're doing all of the encryption in your code before you send it over to the database. You encrypt something, then you send it that way. When it comes to the plugin method, you no longer have to handle the encryption on your own because there's this encryption module, and that's attached to the database. You, as the engineer, still need to be present to install and manage this encryption module, but at least you don't have to manage it in your source code directly. And then finally, there's a transparent disk encryption method. your application is entirely unchanged. There's nothing that you have to do any differently. And the database itself is the one that contains this encryption engine here that transparently encrypts all the data and keeps it safe from hackers should the database ever be compromised. Now, to look at an example, here's an example of MySQL's API encryption method. So here you have to do everything manually with this AES encrypt. It lets you encrypt individual fields. It's quite flexible. So you can see here that you're wanting to update a particular field, the first name of an employee, but what you have to do is call this special method, AES encrypt. And this is just MySQL specific, but other databases are likely to behave in a quite similar method. You give it, of course, the data that you're looking to encrypt, which in this case is the first name, as well as this encryption key here. And this is an AES encryption key. There are different types of encryption, and some are harder to crack than others, but those also take longer to encrypt commonly. So it's important for you to choose the right trade-off between security and speed in your application. And of course, the decryption process is quite similar. Instead of using the encrypt, you use AES decrypt, provided the exact same key, and it's able to turn that data back into something that your application can use. So that's one example done with MySQL. Now, if you're going to be storing user data, it's very likely that you're going to be storing user passwords. And there's one really big rule here. If you take nothing else away, do not store plain text passwords. So if your database, if there's any way your database can be compromised and you're providing, or in there you have users' passwords stored in plain text, you're doing something wrong. So how do you store and verify passwords if you can't actually store and verify the passwords that the users give you? The answer to that is something called hashing. So a hashing algorithm is a sort of, you can think of it as a one-way encryption. It's repeatable, does not require a particular key. It transforms one bit of data into another bit of data, but you can't go back the other direction. And that's important because all you need to be able to do is take the user password, which is this plain text thing, and turn it into this hash product. But you don't want it to be possible to go from this hash back to a password, because then if they compromise your database and got access to hashes, then they could hack you, or they could find out passwords of users. We don't want that to happen. But you might be wondering, since we're not actually storing their user passwords, how do we verify that they put in the correct password? And the answer to that, of course, the hashing algorithms are repeatable. So every time you run this algorithm for the same input, you get the exact same output. What you do is when the user inputs their new password, or where inputting when they're trying to log in, you run the hashing algorithm again, and you compare the product of that to the hash password that you store in the database. If it's the same thing, they put in the same password, and that means that it's correct. There are different algorithms for sexual hashing. Some of them are older and secure, which you should probably avoid using, like AD5 and SHA-1. You should avoid those. There's nice, or I guess the gold standard at the moment is something called SHA-256. But that's likely to change a bit over time, so keep an eye out and do a bit of research before picking a hashing algorithm. It's likely libraries for everyone you're working with that will do this for you. Now, this is an issue with this. If, like I said, these hashing algorithms overturn the same password to the exact same hash, a bunch of other sectors will create something called a rainbow table. What a rainbow table is, it takes a massive list of common passwords, and spend a bunch of time in the computer to hack every single one of those to that hash. This allows people to do, instead of makes it impractical in many scenarios. So of course when you're getting the password back, when you're verifying it, you take their user's input, and then you take the salt, which you've just stored in plain text in your database, put it in the same place, and then recompute the hash. So it's very similar to what we did before. Now, as an example, here's what a salt and a hash might look like in the real world. So you can see the password is apple here. You take this salt, which is just a random string of letters, and this is unique to every single password, so this is not the same for all of the passwords. So you take that unique salt, and you store that in plain text into the database, so you can see that here. That's totally fine. Then you run the product here through the hashing algorithm. You get out your hash, which looks like a semi-random string of characters and numbers, and you store that as well. So the next time when you want to when you want to verify the user's password, you take what they've put in, you extract from your database the salt, you stick it onto the end of their password, and you run it through the hashing algorithm, and you compare whatever comes out the other end to whatever you've stored. And that's how you can securely store passwords.
The next topic is defensive programming, and this is the best way to keep your project secure. If we look at these basic if statements, this is how you can build in defensive programming from the basic building blocks of your code. So function 1 should be run if the string input can be turned into a number, and function 2 is ran with any other input. The problem with this is because anything can be input to make function 2 run. If you're hoping actually for a string and the user inputs something like a boolean at some point, then your program's going to crash, which is why you should use something more like example 2, which deals with this problem. This is using appropriate if statements based on inputs your users may give, and it minimizes the different data types they can input. If you exhaust the inputs they can give, you should catch every error and process the data in the correct way. So you can also see this with case statements. The default match should be avoided at all costs, unless it should be used for error handling generally, because it can cause issues with rogue inputs where you're accepting all, and it allows runtime errors to occur. Although all these things are good, if you're doing a very simple program, over-engineering can also cause problems. If you're overdoing every single bit of code, you can have longer runtimes, and it can cause issues with your debugging. So make sure you use an appropriate level of defensive programming. So next, if you're programming a web app, then you may be triggering HTTP requests, and you may be getting data, so you need to know the right way of doing this. There are different types of requests you can make, and it's very important you're using the right one. So first of all, we have GET requests, which are for getting data from a specified source, as you can kind of see in the URL on the slide. So these parameters can be seen in your browser, so you don't really want to be sending anything insecure. So that's why we have the POST request, which sends the data to the server. The parameters go inside the request body instead of the URL, which means that it's much safer and it's only exposed to the server. They're not saved on the client end, which is why it's secure. There's many different types of requests, but the GET and POST are the most common, especially when you're using web app development. So, for example, when you're submitting a form is the most common time you see this. So, moving on, another thing you may have heard of is SQL injections. So these can be fatal for computer systems, really, and they're very simple to carry out. There's been lots of examples throughout time of SQL injections causing problems with big companies, such as TalkTalk. So it can be very easy to enter just the correct string into an input box on the screen and to cause a lot of damage, as you can kind of see this, or 1 equals 1 in the email field there. So it may sound scary, but there's a few ways you can prevent this from happening and mitigate the consequences. So first of all, sanitization. So this differs between programming languages, but the concepts are always the same. You're trying to minimize the chance for the users to input anything they want. So often if you have a form and you have an input text box, you might want to change this into radio buttons or checkboxes. So they have to choose a predetermined option. And when a different input type cannot be used, validation and sanitization must be used together to make sure that your data is safe and secure from exploitation. So basic sanitization would include checking if the input is a number and if it's a positive number. Using validation in this way can help unwanted inputs being caught. And there is a little chance it will get to the point where it will damage your system. Next is using parameters. So validation is great, but it can still lead to vulnerabilities. It's best to use a combination of techniques. So if we look at the first example, it's using concatenation to build the SQL query, which is where SQL injections can occur. It can be quite dangerous, and it makes it easy for someone to view your database or even delete it. So a better way to handle this is using the SQL parameters in the second example. So the input is replaced by the wildcard you see at the end there. You can use this for an unlimited number of parameters in the statement, for including as many variables you want, which could be user input, and this is a much safer way of handling things.
So I'm going to be talking about cloud computing and how you can use it to develop in the cloud. So what is cloud computing? Essentially a distributed computing service, runs over the internet, and you sort of connect to it remotely, and you can run code without having to run it on your own computer. You're assigned resources sort of dynamically from a pool of actual physical devices that a company's built. So they might have servers sitting in a data center that you can connect to, and it sort of allows you to access more powerful computers than you might have physically on your machine. They're designed to be scalable and resilient to things going wrong, and also highly available. So they might be spread across different regions in case of sort of disaster and power outages and things like that. And you often sort of pay for what you use. So you can use 10 minutes of a really powerful computer and only pay for that 10 minutes without having to buy the hardware yourself. Some providers include AWS, Google Cloud, Microsoft Azure, that kind of thing. So when you're working in the cloud, it's advised that you follow these security principles. Now, a lot of these are quite common sense, and they're not all relevant to sort of a basic software project. A lot of them are for managing these kind of things, but there's some important ones. Sort of encrypting data in transit is important, so you need to make sure you have encrypted sort of lines of communication so people can't listen in on what you're doing. You need to protect your assets, so take backups, protect your data at rest as well, so when it's sitting in a database or in a file, make sure it's protected from people reading it. And you can do things like using sort of AWS's availability zones to help with this kind of thing to make sure it's resilient. You need to have separation between users, so not only authentication but authorization on what they can do, and sometimes in sort of complicated setups, entirely separate networks for separate users, just to stop them interfering with each other if there's a malicious or compromised user on the network. Secure development, number 7, is all about designing your software to identify and mitigate threats. So if you think back to the defensive programming slides earlier in the presentation, it's that kind of thing, and sort of preventing malicious data entry or even mistakes on the part of the user. Secure user management is all about managing the people that have access to your system, and lots of services like AWS and Google Cloud offer ways of managing this to help you. And similarly with identity and authentication, most services provide a way of authenticating your users, and you should make this as sort of specific and targeted as possible using the principle of least access, which we'll talk about in a minute. Secure service administration involves making sure that your sort of high-level admin panels, for example, or access to the highest level of your infrastructure is protected, so people can't sort of gain control of it. And you need to make sure you use the service securely as well. So don't do some things like pushing your passwords to Git or sharing them accidentally. and make sure you understand how it all works under the hood as much as you can. So the sort of SSH and database tips from the slides earlier apply to the cloud as well. So you need to make sure you set up to use secure managed keys. Secure service administration involves making sure that your sort of high-level admin panels, for example, or access to the highest level of your infrastructure is protected, so people can't sort of gain control of it. And you need to make sure you use the service securely as well. So don't do something silly like pushing your passwords to Git or sharing them accidentally, and make sure you understand how it all works under the hood as much as you can. So the sort of SSH and database tips from the slides earlier apply to the cloud as well. So you need to make sure you set up to use secure managed keys, use the SSH keys, and again the provider that you use should help with this. You can separate your database from the public facing internet, so you only have sort of access to your database and your data internally, so once you're on a machine that's part of your network. And this is sort of the security by layers principle that's commonly used. And remember, of course, encryption on your database as well. And secure networking is also very important. So you need to have this sort of least access principle. And in more complicated cloud setups, you might even partition your network. So you only give access to parts of the network that people need specifically. And the principle of least access is all about making sure that access to any part of your system is narrowed down only to people who really need to use it. And the key to this is starting with the minimum possible privileges and adding them incrementally. So you might have different levels of privileges for different types of users. Just like in a normal office where an intern might not be able to access confidential files, you can apply this to cloud computing as well, where you might have your standard user and an admin. And you can apply this to processes as well. So you don't want to give processes and commands and programs that are running on your system the highest possible privileges. Only give them for the services that they need to edit and control. And this avoids situations where a malicious person can sort of hijack your program, use it to do something that it wasn't intended to do. So always start with the least access you can give and keep adding it until what you do works.
Here's the exciting part, finding out what our challenge will be. You and your team will have the chance to win some cyber goodies from us if you have designed Demon Secure project. You can use all the techniques described in the workshop and more. We'll be chatting with you to talk about how you have implemented all your security techniques. Thank you to everyone for coming to this workshop. I know this has not been our usual exploitation content, but I hope it has opened your eyes to the ways you can very easily increase the security in your project. Here are some of our upcoming sessions, and feel free to come along to them. We constantly keep our website updated with our plans for the sessions. If you'd like to find out more about the Society, please go to these links and feel free to ask us any questions. Thank you.